Jai Hind, everyone. Myself, Dr. Ajay Pratap Singh. I am associate professor in Department of Mechanical Engineering, and today I teach here the subject basically theory of machine, the BME 603. In last lectures, I have discussed the different types of to find out the instantaneous centers. So, in this regards, basically, I'll discuss here the examples of how to draw the instantaneous centers for any body. So, for any mechanism. So, I'll discuss quickly. Actually, I have discussed in there the Arnold-Kennedy theorem with the Arnold-Kennedy theorem. If three body moves in relative to each other, they have three instantaneous centers, and it will lie on a straight line, and it will calculate it through for the instantaneous centers. You calculated through we can say uh, the one formula we have discussed, that is capital N equal to n into n minus 1 by 2, where small n is the number of link, right? So, I have discussed, and second thing I have discussed there, basically you can see now we can say the types of instantaneous centers. One is the fixed instantaneous centers, second one in the neither fixed, second one in the permanent instantaneous centers, and third one is the neither fixed nor permanent instantaneous center. So, we will find out all these three instantaneous centers in the 4-bar mechanism or the cylinder crank mechanism. So, I will discuss here for through one example. So, I will come to directly to the examples, and we will find out how to calculate or how to draw the instantaneous centers for the 4-bar mechanism, and another is the slider crank mechanism. So, for you can see in this figure, basically you can see here, if the just recall them, basically we can say if the two link is joined in a pinpoint, so that the instantaneous centers will lie on the at that point, right? So, you can see there that there are different types of the positions. If suppose if any body the fixed and second body is sliding on this, so instantaneous centers lie on a infinite position, right? So, you can see here that the one body is here and one body is here. So, the slider is slide on this fixed link. So, this instantaneous center I want to lie on the infinite. So, there are 5 cases I have seen here, and I have discussed in the earlier cases. So, I will come to this directly point to how to find out the instantaneous centers. So, I will discuss the one exercise. You can see suppose one questions is given in uh, basically a pin joint in the 4-arm mechanism shown in figure, and the length of AB is the 300 mm, and BC and CD is the 360 mm, and AD is the 600 mm, and the angle of BAD is the 60 degree, and the crank is rotate the 60 uniform uh, velocity. The crank is rotate, crank AB is the rotate uniformly at 100 rpm, and locate the instantaneous center and find the angular velocity, right? So, you can see you can draw here basically that the one link, the here the given data you can see the AB link, the here you can see the value of AB equal to 300 mm, this is the crank, BC and CD equal to 360 mm, and the value of AD equal to 600 mm, and angle of ABD angle of BAD equal to 60 degree. So, if you draw this figure, so you can see here that the link, the 4-bar link I can draw here. This point A, B, C and D, where AB, you can see here that the AB is the 300 mm, BC and CD 360, and CD is the 360, and AD equal to 600 mm, and this angle is the 60 degree. So, what is This is general type, but what is the basic process, how to draw this 4-bar mechanism in the real scale? So, if you find out, just I'm putting here, but I'll show how to draw this 4-bar mechanism. So, first of all, I erase there and then we'll discuss. So, first of all, take the point A, right? One point A, and draw the line AD, that is the fixed line. A and D, already a figure is given. So, the distance between this length is the 600 mm. So, you can mark the 600 mm. You can take the scaling. Basically, you can see that you can take the scale in the draw. If you draw in any copy on paper, so that you can take the 100 mm equal to the 1 centimeter. So, you can draw the 6 mm, then 6 centimeter, 3 centimeter, 3.6 centimeter, 3.6 centimeter. After that, you can draw the angle BAD with a 60-degree inclination. So, you can use the D and draw the 60-degree, and these angle, suppose this is the 60-degree, and mark with 60-degree, and the length of this is the 300 mm. You can measure with the scale, right? After that, how to draw B to C and C to D, right? So, you mark there, you can mark the take the distance in the prakar, and you can mark here that this is 360-degree, this angle, right? So, you can draw like this, take the center point and draw like this, and you can again 360-degree to point D you can draw. So, these point is cut somewhere, you can mix up to match this point B to C. These point will find out the C, and this point is C to D, and these both are the distance is the 360-degree, because we don't have the angle of ABD, we don't have the angle of BCD, and we don't have the angle of ADC. So, if you mark with the protector, so you can mark here basically the 360 at point D, and 360 point B you can mark the 360 degree length, and the point D you can again mark the 360 degree. This point is cut at some point. This point you can say that angle of C, that point is the C, and these point in mix match with the point B and draw the line from C to D. So, this angle is, you have draw the accurate, we can say the 360-degree from B to C and D to C, right. So, these we have draw this the 4-bar mechanism. After that, what will given, that is the N. N is given, basically you can say N B with respect to A equal to 100 RPM, right. So, what is the value of omega AB? Omega AB equal to 2 pi n by 60. So, here 2 into 3.14 into n value is 100. So, divided by 60, and it becomes the omega AB equal to 10.47 radian per second, right. So, this is the point we can say, and the length of link is AB already given, that the 300 mm, that is the 0.3. So, therefore, the velocity of B of the link AB, right. So, how much you can see in this figure, and you find out how much link is there. So, there are 4 link is there, 1, 2, 3, 4, right, and how much the instantaneous centers. So, we can see, use the formula capital N equal to N into N minus 1 by 2, where small n is the 4, total 4 link is there. So, 4 into 4 minus 1 divide by 2. So you can find out 4 into 3 divided by 2, that is 2 to the 4. So that 6 degree of freedom is possible in this case. Sorry, 6 instantaneous center is possible in this case. So how to draw this instantaneous center? And after that, drawing the instantaneous centers, we have find out and measure the value of B with respect to C. So draw this again, just I clear all these things. So we need the 6 degree of 6 instantaneous centers. So how to draw? First of all, you can see that the point 1, 2, 3, 4, right? So this point is I point link number 1 and 2 mix up. So one matches. So I 1, 2. This point I 1, 2. This point link 1, 2, 3 and 4, right? So I 1, 2. This point link 2 and 3 is mixed. I 2, 3. This point 3 and 4, I 3, 4. And this point 4, 1, 1, that is I 4, 1. These are the 4 instantaneous centers we have. In this case, basically I 1, 2 and I 4, 1 is the fixed instantaneous centers, and I 2, 3 and I 3, 4 is permanent instantaneous centers. Now we find out missing 2 instantaneous centers. So how to find out? So first of all, draw a circle, right? And locate all these all these 4 linkage in this point 1, 2, 3, 4, right? This one 1, 2, 3 and 4, again 2. So you can cross this and mix 1 to 3 and one is 2 to 4. So this one is the 5 and this one is the 6. So I one link is I instantaneous center is I 1, 3 and second is on I 2, 4. So you can see here there are 2 triangles in case of I 1, 3, that is triangle number. Just I will write here triangle 1, 2, 3 and triangle 1, 2, 3 and 3, 4, 1. 3, 4, 1. In case of I 2, 4, there are 2 triangles, that is 2, 3, 4, triangle 2, 3, 4 and triangle 2, 3, 4 and triangle 4, 1, 2. There are 2 triangles, right? So you can see this key that is I 1, 2. I'll show here that the instantaneous center I 1, 2, I 2, 3, I 3, 4, I 4, 1, right? So you can see that the I centers is here. I 1, 3 in in triangle I 1, 3. How much I center is come here? So you can see that is I 1, 2 and 2, 3. So you can see I'll write here I 1, 2 and I 2, 3 and triangle 3, 4. You can see that triangle triangle 3, 4, 1. So 3, 4, 1 I 3, 4 and 3, 4, 1. So that is I 3, 4 and I 4, 1, right? So we have extend the line this point 1, 2 and 2, 3 line. So 1, 2 and 2, 3 line is there. So I extend here. So I extend here. I 1, 2 and 2, 3 extend that point in upward and downward direction, right? And the point 3, 4 and 4, 1 is extended. So 3, 4 and 4, 1 extended in upward and downward. So these point is cut in somewhere, and this point is in below side, that is not cut, right? So you can see these point is find out I 1, 3, right? So second point, we find out the instantaneous centers from the triangle 2, 3, 4 and triangle 4, 1, 2. So you can see here 2, 3, 4. So I 2, 3 and I 3, 4, right? And that 4, 1, 2, 4, 1, 2. So you can see that I 4, 1 and I 1, 2. So you can check also ki how you have taken this I centers is correct or not. So you can see that the I13, we are determining the triangle I13, I intended I13. So you can see that in the triangle 1, 2, 3, that 2 is the common, right? I am right here in the different color. So you can find out in the green color. So you can see that 2 is the common in this triangle 1, 2, 3, and 4, 1. That is triangle 3, 4 is the 4 is the common, the 2, so that 3, 1 and 1, 3 here, right? Both are the same thing. In that case, that you can see that 3, 3 is the common. So you can see that 2, 4 you can find out, and here that is 1 is the common, that you can find out the 2, 4 also. So if you draw the continuation of 2, 4, so what will extended, that 2, 3 and 3, 4 extended. So 2, 3 and 3, 4 line will extended, and 4, 1 and 1, 2, that 4, 1 and 1, 2 is extended. So this line, that point is cut at that point. This point called that I 2, 4. These points is known as instantaneous centers, and these point of the 2, 4 and 1, 3 is known as neither fixed nor permanent instantaneous centers, right? You can calculate. See, after that, velocity of point B is known, that is omega AB into length of the AB, omega R into omega. So we have the omega AB in previous slide, we find out 10.47 into length of the point, length of this length is the 0.3 meter. So that you can multiply by 0.3 meter. So equation becomes the velocity of point B is the 3.141 meter per second. So you find out the velocity of point B, right? So let us the question we find out the angular velocity of link BC. So how it will find out the angular velocity of this link BC, right? So we find out here the angular velocity of link BC, right? So let us angular velocity of BC. So we can see here in this velocity instantaneous center diagram. So we can see the since B, we can see the point B is the common. B is also point on link C, the common point, and therefore the velocity of point B on the link C. So velocity of B, we can see velocity of B equal to omega BC into I13B, right? So we can measure this point, the velocity. So by measurement of I13B is the measure. So it becomes like approximately the equation becomes I13B becomes, you can say that after the measurement at the 0.5 meter, and we know that omega BC equal to velocity of B upon I13B, right? So velocity of B already you have find out. So value of this one is 3.141 divided by I13B, that is that value of 0.5. These value which comes basically from the measurement, right? So the equation becomes that you can say that the omega of BC equal to that's 6.282 radian per second. In similarly, we find out the angular velocity of link CT. So C is the common point, right? So we have find out the angular velocity. So velocity of C with respect to B again calculated, R into omega. So omega is already find out, and then R is given. R is the 360. So you can find out the velocity of C with respect to B. Now come to this. I hope you understand. Now come to this second exercise. to locate the instantaneous centers of the slider crank mechanism. Both are the same thing, but one is the different. Basically, you can see the slider. You can see in this figure again. Again, the 4 link is there in case length crank A, B, C, D all given in the figure. So we have drawn the same patterns, same parameters. Same patterns we will draw to take the point O and then again using this DN protector and then according to that take the length and then mark them and then you can draw. So these are basic geometry for drawing this the slider crank mechanism or the 4-bar mechanism. After that, again calculate the number of instantaneous centers. Obviously, the 4 link is there, so process is the same. N into capital N equal to N into N minus 1 divided by 2. So again, that the capital N equal to 4 because small n equal to capital N equal to 6, the small n equal to 4 here. So you can calculate 4 into 4 minus 1 by 2, where that the instantaneous center is the 6. In that case also 6 instantaneous centers, 2 is the fixed, 2 is the permanent and 2 is the neither fixed nor permanent. So you can see here the difference is there. Basically you can see I14, basically you can see here that's the slider 4. So all the fixed link, if you counting this number of linkage, so all the fixed link 1, 2, 3 and this is the 4 and this is the 1, right. Fixed is the all the fixed link is count as the 1 link. So if you draw this instantaneous centers here, what will happen? The slider moves along this line, will move the instantaneous centers, find out at that point between to that point the infinite, and this becomes I14 because it connected the 1 and 4. So I14 will come at infinite and it moves between these, right. So you can extend this line, cut this point, and you can extend this line, you can cut this point. So this point is known as I24 again, and this point is the I14, I13. And you can measure the value where velocity is required. So you can measure and then put in this the formula and get the results. So you can see that this link R into omega, omega is known, the velocity of this point is given, right, V equal to R into omega. So omega is the 10 radian per second. So you find out the link velocity of the velocity O with respect to B. So velocity of OB, the omega OB, this value is given, right. After that you can measure this value and find out. So you can measure this value from, you can measure I13A. So this point I13 where you can measure and find out that measured value the 560 mm, that's the velocity of a slider. So we use the formula V A upon I3A equal to BB upon I3B. So I3B already measure, and then you can find out the velocity of point A. Again the angular velocity of the connecting rod of the AB. So you can find out the connecting rod of this length. So you can find out the connecting rod length, and again you can draw, you can measure the value and draw this. So these are the basic rules of the drawing of this instantaneous centers method. I hope you have understand. In case of 5 linkage, 6 linkage, you can again draw the circle and put up all this link and join the lines and then calculate, right. So if link is the 6, small n equal to 6, so in that case n equal to n into n minus 1 by 2. So in that case we can say 6 into 6 minus 1 divided by 2, that is 6 into 5 divided by 2, that is you can say 15 instantaneous centers. In case of 4, in case of n is the 5, so in case 5 into 5 minus 1 divided by 2, so you can say that 5 into 4 divided by 2, the way to how to calculate the instantaneous center method, and you can find out the velocity, right. So thank you so much. I hope you have understand all these instantaneous centers, and if you have any query regarding this, please feel free to call us or mail us. My mail ID is pratapajay@akgc.ac.in. Thank you so much.